Hello and welcome to this new DIY Engineers video. In this video, I'll be covering the ESP32-Cam. I'll be covering basics, how to program an Arduino IDE, how to wire it for programming and general use, and we'll go over several examples, including sending data from the ESP32-Cam for accessing pictures and video via a web browser, taking a picture when triggered by a sensor and saving that picture into the SD card, and we'll even do an awesome computer vision example in which we'll process live video from the ESP32-Cam and use it to analyze objects. In this example shown here, detect a book and a sports ball, for example. So let's go ahead and get started. So this is the ESP32-Cam. This is a small camera module that runs on the ESP32S chip and uses the OV2640 camera. This guy right here. The ESP32-Cam can also be used with the OV7670 camera, but the OV2640 is better. It has a higher resolution and built-in JPEG encode, which removes the processing task for the ESP32. The ESP32-Cam comes with the ESP32, so it is Wi-Fi capable, is Bluetooth capable with 4.2 Bluetooth Low Energy. It has a built-in LED flash, it has 9 I/O ports, supports UART, SPI, I2C, and PWM. It has a built-in SD card reader, this guy right here, and allows for input power between either 3.3 or 5 volts. It's actually reported that powering with 5 volts is more stable than 3.3. Now, as we said, here's the camera, this guy. It's a 2 megapixel camera, again the OV2640. It has an array size that can go up to UXGA, so 1600 by 1200. It has a lens size of 1/4 inch or 6.35 millimeters. And it has a max image transfer rate of 15 frames per second. So at a very affordable price, it's a really good overall system with a built-in camera. So now let's talk about the pins. Now here are the ESP32-Cam pins. So first we have the power in. You can put 5 volts or 3.3 volts, but 5 volts is recommended. We have ground. We have VCC, which outputs 3.3 volts. You have I/O pin 16, which can be used without issues for all general purpose I/O. Then you have I/O pins number 1 and number 3, which are used as the UART interface. Now, since the ESP-CAM32 doesn't have any USB support, they are used to push the code into it. These cannot be used for anything else. Other I/O pins are also used for other purposes, as well as general I/O, but this includes micro SD card and Wi-Fi driver. So it is likely you'll have issues using them for other stuff, especially during boot. So be careful when using the other ones. Another thing to consider is that whenever you're pushing a new program via Arduino into your ESP32-Cam, you must connect I/O0 with ground. I'll show this in future diagrams, but it's just something that you have to keep in mind. Now, let's look at the components on our ESP32-Cam. On front, we have a micro SD card socket where you can insert a micro SD card and use it, for example, to save the pictures taken from your ESP32-Cam right into the SD card. We'll actually be looking at an example of this. You also have the camera connector, and we have the LED flash. On the back, we have a built-in antenna. You also have an external antenna connector, and we have the reset button. We'll be using the reset button for some of our examples today. Now, as you may have noticed, the ESP32-Cam does not have a built-in USB port, which obviously helps to keep the size small, but as a result, we have to use an FTDI programmer to program our ESP32-Cam. All you have to do is wire your ESP32-Cam, as shown in this image, with your FTDI device and connect it to your computer via USB to push the code. Now, as I said before, you have to connect I/O0 with ground within your ESP32-Cam to allow it to program. This is basically means I/O pin number 0 has to be low during flashing. Also, make sure to set the FTDI jumper to the correct setting. Basically, let's set it to 5 volts. Now, once you complete the programming and are ready to test your program within your ESP32-Cam, all you have to do is disconnect this and repower it. Now, before we proceed, let me show you how to set up the camera on your ESP32-Cam, because it's very likely that when you received it, it was not set up already or not connected. All you need to do is lift that tab that I just lifted and carefully insert the connector of the camera into the slot. As you can see, I'm trying to be careful, and then we bring it down and snap it. Once you do that, you'll be all set. Do a little tug, not too hard, to make sure that it's in place, and we're good to go. Now, we also want to make sure that we hold that camera down so that it's laying flat, and want to make sure we remove this little piece of paper so that we can see clearly. Now, in order to use the ESP32-Cam with Arduino, it will require that we add the appropriate JSON file within Arduino IDE. So this is done in Arduino IDE by going to File Preferences, and then within the Settings tab, which I already have open, you'll go towards the bottom and you'll see this section that says Additional Boards Managers URLs. Let me expand this, and you can see that now I have the two after I already added it. This is the original one I had, and we have to add now a second one for using with the ESP32-Cam. So you need to add this one. And if you go to my website on DIYengineers.com, I have the link in the description, you can easily go there and copy the link to the JSON file, which I'll show briefly so you can see. But here's my blog post. If you scroll down enough, you'll see the section that says JSON file. Just copy and paste this link into Arduino IDE. So once you have pasted it, make sure to click OK and put it in a separate line, and then click OK as well again. Now, you also need to add ESP32 board to your Arduino IDE. So once the correct JSON file has been added, you need to select the appropriate board. So we go to Board Manager, so we go to Tools, go to Boards, and then we go to Board Manager. And then you search for ESP32. And I already have it installed, but you would select this one and click Install. Once it's installed, you'll want to go to Tools, Board, ESP32 Arduino, and then you want to scroll down. You have to be patient to find the one called AI Thinker ESP32-Cam. Right here. If you have trouble finding it, it's between this frog board and this TTGO T-Watch. So like that. Now let's go ahead and start our first example. As talked before we send any programs into our ESP32-Cam, we need to make sure to set up our wiring and connections properly with an FTDI programmer. So let's do that right now. Now, as you can see, you need to set up your FTDI with your ESP32-Cam as shown in the image here. I'll give you some time to take a look at it and pause the video if needed. Alright, so set it up like this, and then let's go back to Arduino IDE. So, once you set it up as we talked, all you need to do is go to File, Examples, ESP32, Camera, Camera Web Server. And this is the example we need. Now, as you can see in this first section, you have to select your camera model. Let's go ahead and comment these, and uncomment these that say define camera model AI Thinker. Okay, so you can also see if you keep scrolling down, there's a section that says enter your Wi-Fi credentials. What you need to do is here, put the name of your Wi-Fi network that you're going to use. So the one that your computer is currently connected to, the one for your home. And then enter here the password for that Wi-Fi. So now we go ahead and click the upload button. Note that before hitting the upload button, I went ahead and entered my Wi-Fi info as well as the password. So now that the code is uploaded, remember that before you do anything else, you need to unplug or disconnect this pin IO0 with ground. Then reset your ESP32-Cam and proceed from there. So once you have disconnected like we talked, let's open the serial monitor and reset your ESP32-Cam, and you will see a message. Then it will say Wi-Fi connected, and you will see the IP address to use to connect. Copy that IP address and then paste it on your web browser, and we'll go from there. So I went to my web browser and I copied and pasted the IP address, hit enter, and this opens. So you have multiple settings here to pick your resolution, quality, brightness, contrast, saturation, etc. If you hit this button, you can start getting live video from your ESP32-Cam. So I'm gonna do that. And you can see what I'm getting. Now, one thing you'll notice is I'm getting this like horizontal lines that kind of like pop up and make the video not look as great. That is happening because I'm powering my ESP32-Cam directly from the FTDI. If I use some other more stable power source, all that goes away. Go ahead and give it a try. But as you can see, here we have the output video. I could go ahead and change this to something else, either less resolution or more resolution. So you have multiple options to test for what works best for you. All right, this completes example number 1. Now let's go ahead and move into example number 2. In this example, we'll be taking a picture with the ESP32-Cam and saving it to a micro SD card, as you saw earlier, in the embedded SD card. Note that the ESP32-Cam is ready to work with SD cards up to 4 GB in capacity. This has been reported actually to be able to be used with up to 16 GB, but 4 GB is the spec. Now, the program will have the ESP32-Cam rest in sleep mode. Then we will wake it up via the reset button that I showed you earlier on the back. Then a picture will be taken, and this picture will be saved on our micro SD card. Now, step 1 in this example is to take our micro SD card and format it to FAT32. To do so, connect the SD card to your computer, then go to this PC or my PC, right click on the specific SD card, then click on format, then make sure you have FAT32 picked, make sure quick format is selected, and click start. And once it's complete, click OK, close, and you're done. Once you have done that, go to DIYengineers.com, specifically follow the link in the description to this video, and scroll to the example where I have take this picture and save on SD card. Scroll down, and you'll see an Arduino code. Make sure to copy and paste that into Arduino IDE, and we'll go from there. Now, as a reminder, I'll show you the images here. This is the setup for programming, and this is the setup for normal operation. So once you have copied and pasted the code into Arduino IDE and have your ESP32-Cam wired with ground and IO0 connected, go ahead and click the upload button. All right, so then remember, unplug your ESP32-Cam, unplug IO0 from ground, and then now anytime you restart it, it's going to take a picture. Alright, so as soon as I turn on our module, it will turn on the flash, and then anytime after that in which I push this push button, reset button, in the back of our ESP32-Cam, it will go ahead and turn the flash again. So let's first turn it on. You can see the flash. And I'll push this push button right here in the back, you'll see. Do it again. So as you can see, anytime we reset the ESP32-Cam module, it resets and it goes through the sequence that we showed in Arduino IDE. It flashes, takes the picture, saves it on the SD card. Alright, let's go look at another example now. Now, in this new example, it will be basically the same as the one we just completed, except now the picture will be taken whenever a PIR sensor detects motion. If you want to learn more about PIR sensors, check my previous video. So basically you can substitute this sequence that I'm showing here, this second step, with any other sensor that basically when it provides a high signal, the picture will be taken. It could be even an external switch. And then actually, before we go into the PIR, I'll show you how to do it with a push button. So for here, we'll use a PIR sensor. So now we need to figure out how to wire our system. So before we jump into it, there's something critical to take into account, and that is that the ESP32-Cam already uses a bunch of I/O pins for the camera and for the SD card. So things get tough when we have to choose to add another I/O into the mix. Additionally, from the previous code, remember that we're basically taking a picture and sending the ESP32-Cam into a deep sleep. So we then have to wake it up to take another picture and then back to sleep. So previously we were using the reset button to wake it up, but now we're going to use an external signal. So what pin can we use? When the ESP32-Cam is in deep sleep, only the low power portion of the system is running, which is great for power saving, but as a result we can only use pins 2, 4, 12, 13, and 14, as well as 15. Additionally, I mentioned that the camera and the SD card are using many pins, so whichever pin we select needs to be free when we're not trying to reset the ESP32-Cam. To do this, we will add a 2N2222 transistor, which you can learn more about in another previous video as well. And the goal is to simply link our I/O pin to ground when we want to reset the ESP32-Cam, and then isolate it from all the other pins at that when we're not using it basically. For this, I picked I/O pin 13. This is after trying the other ones with no luck. Now, as I tried to test multiple pins, I tested the system using a push button, and then I move into the PIR sensor. So let me show you now how to wire it for the push button. Now, as we looked at the wiring diagram for our example, we can see that ground on our ESP32-Cam goes to the common ground, which also connects to the collector on our 2N2222 NPN BJT transistor. The base connects to a 4 kilo ohm resistor, which connects to our push button, which then goes to our 5 volt. Those 5 volts also go to the 5 volts input of our ESP32-Cam, and that ESP32-Cam digital input connects to our 10 kilo ohm resistor, which connects to the emitter. Now let's go ahead and set up our example. So let me quickly set it up. I'll speed up this so you can see, but it's not that many steps, and we can quickly get our example going. So I'll now turn it on. As soon as I turn it on, it's just treated as a restart, so you'll see the flash. And then, as soon as I hit the push button, it will go through the same cycle, flash, take the picture, save it in the SD card. Do it one more time. Alright, so let's power it off. And now that we've tested this, let's try it with the PIR sensor. So now this is basically the same circuit we just looked at, with the minor difference that now instead of a push button here sending the signal, we're sending the signal via the PIR output, which by the way will connect to ground and also to the 5 volts. And again, you can check out my video on PIR if you need to learn more. So now let's go ahead and change the circuit from push button to PIR sensor. Now we can go and test it, and again, as soon as I turn it on, you'll see the flash. Okay, and now instead of the push button, if the PIR sensor detects the motion, it will light up. So there, I guess I was too close to that side. Try it again. And again. One more time, just for fun. All right, So as you can see, we're able to test the camera to auto take a picture and save it on the SD card by using either a push button or in this case a PIR sensor, but really you could use any sensor that you want to trigger the camera to take the picture and save. That could be like a limit switch or any proximity sensor, like for a security system, etc., etc. All right, let's move on. So now we'll jump into the fourth example, which is doing vision processing with OpenCV. So if you go to the blog post that I've referenced several times, go ahead and scroll to the section for this example and click on this link to get to the right page to download Anaconda, which we'll be using in this example. Once you get there, go ahead and download the right installer. For me, I'm using Windows, so I'm going to download the one for Windows. It'll take some time, so let's go ahead and wait until it downloads. Alright, so now it's downloaded and we can continue. So now let's go ahead and open the installer and go through the steps to get it installed. Here, just me, pick the folder, pick your settings. I left it default, click install. This could take a little bit, but then just wait until it's complete and then we're done. Then after that, we'll just go ahead and open Anaconda. So now, once you have opened Anaconda, go ahead and type the following. So it will be conda space create space hyphen name virtual end Python equals 3.11 and then hit enter. I'm not going to do it because I already have it installed, but I'll show you an image of what it looks like. So then once you enter that, you'll get a message saying, hey, the following new packages will be installed, and you'll get a full list, kind of like what's shown here. And then at the bottom we'll say proceed, yes or no. The answer is yes, you want to proceed. So you enter a Y, hit enter, and a bunch of stuff will begin installing. Then once everything is installed, you'll get a message saying, hey, to activate this virtual environment, you want to use the command conda activate virtual env, just shown here. And then to deactivate or get out of that environment, you want to type conda deactivate and hit enter, also as shown here. So now go ahead and get back into your virtual environment by typing conda activate virtual env and run the command pip install opencv-contrib-python. That will go ahead and install a bunch of stuff. Now once that's done, go ahead and run pip install request. I will go ahead and download another set of things. Once that's done, run pip install zvlib. Again, pip install cvlib. And once that's done, go ahead and run pip install tensorflow. And after that, pip install matplotlib. Once all of that is completed, we can go back to DIYengineers.com, again, the blog post I provided the link to, and look for the following Python code. So once you get to this example, now scroll down to the section shown Python code for example, and download this Python code and place it in a simple folder. For me, I have it on my downloads folder, as that's a short path, but you can place it on your desktop or anywhere else. After you do that, we can test example. So as shown in the blog post, it's pretty simple. Basically, you want to complete all the steps listed under example 1, which was the one of sending the video to your computer, except we will not open it via web browser. Then within Anaconda, we're going to activate the virtual environment, and then we're going to go ahead and run the Python code. So for me, I had it on my downloads folder, so I'm going to run it as downloads/test.python or py. So just save this within a text file in a specific folder and go ahead and run it. So now I'm going to show you how that looks like. So now we're back to Anaconda, and step 1 is open the virtual environment. I then go ahead and run the Python command needed to execute my code. If you can see, I actually renamed it to test R3, and we immediately get video output. Now, the speed in which you get your data will depend on how quickly your computer can process and run the whole algorithm for the computer vision, as well as the speed of your Wi-Fi connection, which might be impacted by how far you are from the router, any interferences, etc. But for the most part, I mean, you can see it provides a very good result. We have a ball and a book, and it identifies this as a sports ball and a book. It's not perfect. I think earlier I tried like lemon or an orange and the lighting wasn't great, so it still thought it was a sports ball, but it's still very good. So I hope you enjoy this example. It shows you how you can go from using a simple camera, taking a few pictures, saving an SD card, and you can even use it all the way with, computer vision. So hope you liked it. This concludes the video. I hope you really enjoyed it. If you liked it, please give us a thumbs up and consider subscribing. Thank you very much, and see you in the next one. Bye.